Hi and welcome again. I promised in the previous video I'm going to show you how we name esters. Before we name esters, however, let me just quickly revise what we saw in the previous video in terms of naming carbonyl derivatives. Okay, so of the carbonyl derivatives, we have carbonyl. Okay, carbonyl is carbon double bonded to an oxygen. That is the carbonyl functional group. Now, depending on what happens to the rest of these bonds is going to determine what type of derivative it is. So we had carbonyl bonded to a substituent and a hydrogen. This was called an aldehyde. And then we had the carbonyl double bonded to oxygen, that's carbonyl. Then two substituents, in other words, on both sides we have carbon chains. Now what this means, in an aldehyde, the carbonyl is at the end of a carbon chain. In the ketones, okay, these are called ketones. A ketone, the carbonyl is somewhere in one carbon chain, so we'll count the whole carbon chain. We won't just count this length or that long length. We'll count the whole carbon chain and name it accordingly. So the carbonyl group is somewhere in a carbonyl chain. Okay, and then we had the carboxylic acids. That was a carbon and oxygen. That is where the carboxyl comes from. Carboxyl. Okay, carboxyl is a carbon oxygen bronze. Carboxylic acid. Okay, carboxylic acid. That is where I have on the one side a carbon chain, or an alkyl group and on the other side I've got I'm bonded to hydroxy or hydroxyl branch on that side, in other words a hydrogen and oxygen branch, and the hydrogen stopped the chain right there. It can't bond any further. This is carboxylic acid, and this is actually the important part, because an ester looks very similar to a carboxylic acid with one difference. An ester has a double bonded carbon bonded to a carbon chain bonded to an oxygen, but instead of bonding to a hydrogen, it is further bonded to a different substituent. So its carbon chain continues on that side. But what's different between the ester and the ketone that also has a carbon chain here is that the carbon chain is broken. Okay, so I have a carbon chain, a long length of carbon chain on this side, but on this side that's not a continuation of my carbon chain. This carbon chain here is not connected to that carbon chain. Well, they are connected, but they're not connected with another carbon. So this one has two parts to its name. Always, an ester always has two parts to its name, where this one will form an alkyl branch. Okay, this is an alkyl branch. That's also an alkyl branch, but this forms the main part of the name. So this one will form the basis for the name, and in front of that basis we will write the alkyl group. Okay, so the alkyl group is the one that is bonded to the oxygen, and the basis is this long chain here. So it doesn't matter which chain is longer, it's all about the carbon double bonded, the chain bonded there, and then this one would be the alkyl group. Let's look at an example. Okay, so obviously the simplest example is where I have a carbon double bonded to an oxygen, single bonded to a hydrogen, bonded to an oxygen, bonded to a carbon, and 3 hydrogens. Okay, so now notice the moment I have this in my chain, COO, if it was an H, it's a carboxylic acid. Okay, I've got my COO, but the moment it is a COOC, this changes into an ester. So an ester must have this in its condensed structural formula. This one is HCOOCH3. This is the condensed structural formula for this one. What is this one called? Well, again, we have to notice that the branch bonded to the oxygen, this is an alkyl group. In other words, this is literally a branch, and that branch will form the beginning of my name. This is methyl. That's methyl. Okay. And I didn't mention it here, I mentioned in the previous video, for esters we use the suffix, we'll use the suffix -ate. Okay, so this is methyl, methanoate. Okay, why? Because in the basis, the basis for this name is, that's the basis, there's one carbon, so it's methane, and then because this is an ester, it's -ate. Okay, let's look at a slightly more complex name. So if I have a carbon double bonded to an oxygen, bonded to a carbon which has 3 in there, bonded to an oxygen, bonded to a carbon, each one of them has their hydrogens. Okay, so I'm not going to write in the hydrogens, I'm going to simply name this one. So notice that these are all hydrogens. So we first need to find our ester functional group. This tells me it's an ester functional group. The branch connected to the oxygen, that branch there is literally my alkyl branch. So in this case, it is propyl. Why propyl? Because I've got 3 carbons, that's the prop, and then because this one is going to be considered a substituent or a branch, it is -il. And then this one's name, or the basis for this one's name, only contains 2 carbons, making it propyl ethanoate. Ethane because there's 2 carbons in the basis of this name, and then the -ate because this is an ester. We have the COO, the COOC, that makes it COOC, that makes it an ester. If it was COOH, it's an carboxylic acid, so just be careful for that one. Now, one part of this that is important, or a conclusion or an introduction maybe even to this, is the fact that an ester is the result of a carboxylic acid. The way we prepare an ester is taking a carboxylic acid and adding an alcohol, and this would produce an ester. Now, the carboxylic acid is literally the basis of this name. The alcohol is the branch. So in other words, this ester here, this propyl ethanoate ester, is produced by taking the prop alcohol, which is propanol, and adding it to ethanoic acid. So that's another way in which you can realize or recognize how these esters are named, is by recognizing what did we use to produce it. If we used propanol and ethanoic acid, it produced a propyl ethanoate. If I were to use methanol let me actually use just a different color again. If I use methanol and add it to, let's say, propanoic acid, it will produce, it will produce methyl propanoate. Methyl propanoate. So what does that one look like? Well, we know that because of the O8, we have a carbon double bonded to an oxygen, single bonded to another oxygen, bonded to this carbon. In the base of the name, we have prop, so there must be 3 carbons. Okay, we have 1, 2, 3 carbons, and then hydrogen, and this one also has 3 hydrogens. Okay, propanoate is the propanoate, and then the methyl means bonded to this one would be a methyl group, so carbon like that. Okay, and this will be exactly the way in which we name esters.